Hi, so in this session of STR8CHEM, we're going to talk about how to construct the most plausible Lewis structure for expanded octets, okay? For a central atom that will be able to expand its octet to go beyond 8 electrons surrounding it, it must be from a period 3 and onwards, which is non-metals. Okay, so far we have talked about central atoms on the second period on the periodic table. Therefore, those species will not be able to expand its octet. Okay, but for the atoms or the elements on period 3 onwards, period 4, 5, and 6, they have the ability to expand the octets because they have d orbital characteristic. So when you are asked in exams why certain species would be able to go against the octet rule, that is because it is on period 3 and onwards, and usually they can use period 3 elements, and they have d orbital characteristics. So you have to mention those 2 points. Okay, when you are able to expand the octets, the central atom can have more than 8 electrons. Okay, so far we have looked at the example for carbon, nitrogen, oxygen for the central atom, and these elements over here are from the second period. Okay, so when they are at the second period, okay, when they are on the second period, they cannot expand the octet. So that's why they have maximum number of bonds for carbon 4, for nitrogen 3, and it has 1 lone pair. Oxygen can have maximum number of bonding pair 2 and 2 lone pairs. And then when they have more than maximum, usually extra 1 bonding pair, they will gain a positive charge. And then when they are less than the maximum, they will gain a negative charge. So you need to remember these species over here on period 2, they cannot expand the octets, therefore they have maximum number of bonds, and also they have lone pairs. Okay, so now let's have a look at the example for expanded octet species. Over here I have SF6, okay, sulphur hexafluoride. Sulphur over here will be the central atom. Why? Because it is more electropositive than fluorine. Okay, sulphur is in group 16. Fluorine over here is in group 17. So when you are in group 16, you have 6 valence electrons. When you are on the 17th group on the periodic table, you have 7 electrons. If you look here, now you can see that even though sulfur is on the same group as oxygen, group 16, but it will be able to form more bonding pairs. The reason is because this sulfur over here is on period 3, therefore it has d orbital characteristics, and thus it can expand its octet. So step 1, it's the same thing. You're gonna try to calculate the total number of valence electrons involved in the construction of the Lewis structure. Just now we have identified sulfur will have 6 valence electrons because it is situated on group 16, or alternatively you can try to write down the SPDF notation, and then from there you will be able to find out the valence electrons. And so you have fluorine over here, which is on group 17, therefore it will have 7 valence electrons. To make SF6, you need to have 1 sulfur atoms, that one will be 6, and another 6 fluorine atoms, that one you will have about 42. Okay, so you will have 48 valence electrons in total. So you will get 1 mark right over there. Okay, moving on to step 2, we're gonna draw the Lewis dot symbol for sulfur and fluorine. Just now we have talked about who will be the central atom, and it will be sulfur. Why? Because it is more electropositive than fluorine. So you're going to distribute that equally like this. So when you look at it, it looks quite similar to oxygen because they are from the same group. But later on, you will realize why. You will know why sulfur is able to form expanded octet due to the d orbital characteristic. Okay, so you're gonna have all the fluorine atoms as a terminals atom. Okay. So after you have drawn the correct Lewis dot symbols for all of them, you will be able to be given 1 mark right over there. So step 3, we're going to draw the bonding pairs on the sulfur and fluorine atoms. So just now we have talked about why sulfur is able to form expanded octets. So to know that, you have to look into the orbital diagram of sulfur. So we do know that sulfur has 16 proton number, therefore it has 16 electrons. The SPDF notation would be 1s2, 2s2, 2p6, 3s2, 3p4. You have 16. And when you look here, that is the indication that your sulfur atom is situated on period 3. And when it is on period 3, it will have d orbital characteristic. What does it mean by d orbital characteristic? So if I'm gonna take that, okay, if I'm just gonna take this one, you're gonna draw 3s, gonna look at the orbital diagram. You have 3p, so you have 2 electrons over here, and then you have 4 electrons right over there. Okay, when you look at this orbital diagram, you might gonna say to yourself, oh, it has 2 unpaired electrons, and how can it form 6? Okay, the reason is because, like what we have talked about just now, it has d orbital characteristic 1, 2, 3, 4, 5. So you have empty 3d orbitals ready to accept electrons. Okay, so this electron and that electron over there will be excited to here. Okay, it will be excited to 1 and 2. Okay, so that one is excited, becoming this, and that one is excited as well, becoming that one. So now when you look at this, you have 1, 2, 3, 4, 5, 6 unpaired electrons. Okay, so when you look at what happened over here, you have 6 unpaired electrons. Because of this phenomenon over here, this one, unlike oxygen, that and that is not, can be unpaired electrons. Okay, because it has the ability to do this. All right, so do not mix this up with oxygen. Oxygen cannot form expanded octet because oxygen is situated on group 2, on period 2. So period 2's elements will not gonna have the ability to form expanded octet because they do not have d orbital characteristic. It's only for period 3 species would be able to have this d orbital characteristic. Okay, so now we're gonna form the bond. Okay, so you have this unpaired and that unpaired. You will form a bonding pair. This unpaired with that one can also form a bonding pair. And this over here with that over there will form another bonding pair. This unpaired with that unpaired will form a bonding pair. And this unpaired with that unpaired form another bonding pair. With this unpaired, you get another bonding pair. So you have sigma bonds around sets. Okay, so this is the most plausible Lewis structure for SF6. You will get 1 mark. So what sort of unusual things over here? This is your expanded octet. Okay, so you can proceed if you want to calculate the formal charge. You can do that, and if you want to do for hybridization, also you can be based on this one. Okay.